Today we prove Cauchy-Schwarz inequality. Then use it to prove the triangle inequality. Mathematics. Bravely preventing lengths from becoming nonsense. We use the notation norm of V for the length coming from the inner product. Cauchy-Schwarz inequality says the absolute value of the inner product is at most the product of the lengths. In plain English, one vector's shadow in another direction cannot be larger than the vector itself. A rare moment where the universe behaves politely. Assume V is not zero. If V is zero, the inequality is immediate, and even linear algebra refuses to waste screen time on that. Choose alpha to be inner product of U and V divided by norm of V squared. And set W equal to U minus alpha V. This choice makes W orthogonal to V. So U has been split into an alpha V part and an orthogonal leftover. By Pythagorean theorem, norm of U squared is norm of W squared plus norm of alpha V squared. Dropping the non-negative part gives the bound. Multiplying by norm of V squared and taking square roots gives Cauchy-Schwarz inequality. Somehow the proof survived contact with complex numbers. Cauchy-Schwarz immediately explains why the angle formula is well defined. For real spaces, the normalized inner product lands between -1 and 1. For complex spaces, the real part also lands between -1 and 1, because its absolute value is no larger than the absolute value of the inner product. So the definition gives an angle between 0 and pi. Now we prove the triangle inequality. The length of a shortcut is at most the length of taking the two sides separately. Stunningly, shortcuts are short. Start by squaring the length. Expanding the inner product gives the two lengths and the real part of the cross term. The real part is at most the absolute value. And Cauchy-Schwarz inequality controls that absolute value. See? One inequality doing actual labor. The right side becomes the square of norm U plus norm V. Both sides are non-negative, so taking square roots gives the triangle inequality. Next time we keep the length notation. But stop assuming it came from an inner product. Because apparently we enjoy removing structure and seeing what still survives. A normed space keeps positivity, scaling, and the triangle inequality, but without an inner product. Angles may simply not exist, terrifying, but legal.